Fuses and circuit breakers. Right, fuses are devices that melt if the current is too high. They're a deliberately weak area of a section of a current that will break to prevent any other damage to the rest of the circuit. RCCBs, or residual current circuit breakers, they break or disconnect the live wire if the current is too high. They're the ones that you probably have at home that you press a button to reset it. I suppose they're quite handy in some ways and be able to reset it very, very quickly. But if there's a serious fault in the circuit, you'll find that no matter how often you try to press it in, it'll keep popping out, which means you've got a serious problem in your circuit somewhere in the house you need to have it dealt with. Right, what exactly is a fuse? Well, let's imagine, I sometimes like to imagine electricity as being like a road along which electrons are travelling. These little blue things there are electrons moving from one place to another, and they're sort of running across a bridge. Now the bridge has been made deliberately weak so that if too much current is going across there, it will break, and if it breaks, the whole circuit stops. None of the electrons can move. Okay, so that's really what a fuse does. Let's explain as to exactly how this happens. If we use a kettle, for example, let's imagine this is a metal kettle, and you've obviously got the live and the neutral wire, and they're connected to the heating element. And if you notice on the live wire, you've actually got a fuse as well. The earth is attached to the metal case, and if you follow the earth wire all the way back from the kettle all the way back through the plug, you'd eventually find it's actually connected to a big metal spike in the ground somewhere in your house. Now let's imagine that something happens, that the live wire touches the metal case. Now that is possible because sometimes wires, as you probably know with things like mobile phones, the wires can fray, they can get damaged and broken. Now with mobile phone wires, that they tend to be at very low voltages, but with things like kettles and other domestic appliances, you'll find they'll be at high voltages enough to kill people. So if the live wire touched the metal case, the whole metal case would become live, which means that if you touched it, you would become electrocuted. So the earth wire is attached to it before this whole thing happens, so that if the live wire did touch the metal case, the electrons would go into the earth wire, down into the ground, and you'd have a massive current. And the current would be so big it would blow the fuse, which is what you've got here, is the fuse has been blown because the live has touched the metal case. The current has gone through the earth wire to the ground, it's produced a massive current, and it's blown the fuse. And now, of course, the electric kettle is perfectly safe. Okay, it doesn't work, but it's not going to kill you. So what you do, of course, you look at your kettle, see what's gone wrong. Ah, crikey, the live's touching the metal case. You repair the wire there, and then you replace the fuse, and hopefully that'll work fine. Right, some devices though are made of plastic, so maybe you may have metal cases, so plastic kettles, and in those cases you'll find there probably isn't an earth, because if a live wire did touch the plastic case, it can't go anywhere because the plastic is an insulator, and these are known as double insulated devices. Again, make sure you know that, double insulated, and that's only true for the devices made entirely of plastic. To work out which fuse to use, you have to use this formula, which is power equals voltage times current, or P equals VI. So let's give an example here. A 2000 watt kettle runs at 230 volts. What current should it use? So you should do the calculation now. You can pause it if you wanted to, but here you go. This is the answer. It's I, current, is power divided by voltage, 2000 divided by 230, which is 8.7 amps, and so therefore you know that that's the standard current it will be working at. So stick in a 13 amp fuse, it'll work perfectly fine. Don't stick a 5 amp fuse there because it will blow straight away because it wants to work at 8.7 amps. Another use of the earth cable and of fuses as well is that you have to be you connect the earth cable not in the plugs, but around your house you'll find there'll be occasionally a little green wire going around connecting metal things together, like radiators and the plumbing and other big metal devices. And the reason that is there is to prevent a potential disaster of a live wire touching metal plumbing, because that would make all of the metal plumbing in the house live. So by again sticking an earth cable onto each of those devices there, you can cause any live wire that touches the metal casing to send a massive current through the pipework, through the earth wire into the ground, and because the current was so big, it will blow the fuse and thereby save lives, because obviously people aren't being electrocuted by using the radiators or using their taps. Right, there we go. Oh, one final thing, just on the left-hand side there in pink, you can see it says general rule. The thicker the cable, the larger the fuse you tend to use. That's just a general rule. The thicker the cable, the bigger the current is likely to be, the larger the fuses that you're going to have to use. And that is fuses and circuit breakers.